Yeah. So as I was saying, it's an honor and pleasure to speak to you all today, and I'm going to tell you how machine learning can help to improve manufacturing and metalworking. Information about Industry 4.0, what are the specifics of manufacturing, what problems there are, and how they can be solved by machine learning, and also what challenges there are today in industrial data science. So today, smart manufacturing is empowered by integration of cyber and physical system with the evolution of computing, artificial intelligence, big data, data analytics, Internet of Things platforms, and so on. And this integration enables to develop systems that meet changing conditions in the factory. As you can see on this slide, in this slide, we come from descriptive and diagnostic analytics to predictive and prescriptive. Plans and preventive analytics have the trade-off scenario. Predictive maintenance and predictive analytics is a promising technique that has an ability to break the trade-off by maximizing the useful life of equipment and a machine and uptime simultaneously. It means that it is designed to monitor the condition of equipment and then predict when the equipment will fail. It means that the future behavior and condition of machine equipment components can be approximated, which will help to optimize maintenance tasks. Accordingly, the machine downtime and maintenance costs can reduce significantly while making the maintenance so today, predictive maintenance, predictive analytics systems are in high demand, as much as visual analytics, different decision support systems, and fun fact about all of this, all of them are powered by machine learning today. So some words about manufacturing and metalworking. As you can see, in the complex manufacturing field, there are many elements, human, tangible, intangible resources, and they interact with each other. And that's why a large amount of data is collected and accumulated during manufacturing. And machine learning powered systems are able to handle high dimensional data and reduce complexity, improve existing knowledge, and identify relevant process relations. And these abilities enable to forecast, improve productivity, and the more important product quality. So what problems can we solve with machine learning in manufacturing? In the manufacturing plant, optimal maintenance strategies are necessary to ensure system reliability and also to reduce cost, to avoid downtime, and maximize the useful life of the machine. For example, if work is equipment damage and break or cutting tool failure and predict when it will fail. Also, there are a lot of anomalies that affect parts quality. So we need to build a system that suggests optimal cutting tool replacement time because it affects the parts quality. Also, impacts of unplanned downtime are devastating because some factories lost their business because of it. Some of them lost their customers, but hopefully it all can be avoided. So how? Today we at Cifre AI laboratory are focused on anomaly detection and manufacturing. This solution helps to develop a complex predictive to increase part quality and prevent machine downtime. Having data, we can use various machine learning algorithms to detect anomalies in manufacturing process and to tell operators or engineers what exactly is wrong right now. So first of all, we need to know what factors can cause the anomalies so that we can look at the particular parameters in data set. Then we need to configure data flow if it's not configured yet. And then comes pre-processing of data and, of course, machine learning. So there are a lot of, as I was saying earlier, there are a lot of factors that can cause anomalies for the major factors. Cut and tool quality, machine malfunction, technology imperfections. For example, operator picks the wrong speed for the wrong cut-and tool. And of course, human factor, operators do make mistakes, unfortunately. And what about data? We put parameters into groups, observable parameters and controllable. Controllable parameters are those parameters that are set by a technology engineer in CNC machine program. CNC machine program is like a piece of code for the machine. And observable parameters are the parameters that show the result of technological process. How speeds affect different components of the machine. Data flow is quite straightforward. We need to collect data, pre-process it, have a place to store data, process it, and systemize and analyze. And we get data from the CNC machine. Then data is collected by monitoring system, MDC, manufacturing data collection system, using different connectivity protocols. And then the important parameters go to time series database. But data, the raw data isn't always clean and understandable. So we need to pre-process it. To detect anomalies in technological processes, we need to cycles of the same is one part produced. Also, we should not forget that data isn't always clear and nice. So we need to do some noise duplicates to make dataset more comfortable for analysis and to work with. So for anomaly detection, we use three algorithms: local outlier factor, isolation forest, and long short-term memory autoencoder. Why these three, you may ask? The answer is simple: because we can. We can be sure that there is only one best method for us for this task. In manufacturing, we pay a high price for a failure, so that it's better to use several methods and several algorithms, because we make these models for this particular task and to analyze their metrics, anomaly detection, accuracy, and false positive. In some words about each of them. LOF, this is a statistical method based on a concept of local density, where locality is given by k nearest neighbors whose distance is used to estimate the density. By comparing the local density of an object to the local density of its neighbors, we can identify regions of similar density and points that have a substantially lower density than their neighbors. And these are considered to be outliers or anomalies. Speaking about isolation forests, this algorithm is one of the variations of random forest, random binary decision trees, and further averaging of the results of these trees. For example, so you can see on the slide step-by-step instruction how to use isolation forest. You can go further. And launch short-term memory autoencoder. This algorithm is a recurrent neural network, and a key feature of this model is the ability to learn long-term dependencies. And this is especially important when we analyze time series. A distinctive feature of this model that as series parameters and is trained in such a way as to predict them. So when learning on normal without anomalies, the model will make more mistakes in prediction points. And this will be the signal that anomaly has appeared in the data. So to use this method, you need to train on data that doesn't contain any anomalies. It's necessary to make a forecast of this data in order to obtain the model output, and then you obtain the difference between the output of the model and actual values. We tested these methods using different data sets. Because when solving the problem of anomalies, we are faced with that will maximize the first metric, anomaly detection accuracy, and minimize the second, the false positive percentage. As I mentioned earlier, usually we do not have marked data with labels, so that it becomes really difficult to validate methods that are used. So after experimenting with the described algorithms on different data sets, which were not with manufacturing data but census data, it's a bit similar to what we are having in real life in manufacturing. It can be determined that isolation forest is the best choice for this task. However, it should be noted that the algorithm can be improved by tuning. The next step after detecting anomalies, these anomalies, because to detect anomalies isn't enough to solve the industrial problems I covered earlier. On the step one, we discovered a group of factors that can cause the anomaly. So the next step for us is to classify these anomalies, and for that we will work with manufacturers more closely to create necessary experiments. And that's the different story, not for today. And what are the insights and challenges of industrial data science? It's not always easy to analyze data in manufacturing. There are a lot of obstacles in our way with the lack of data and markup and labels. And usually we face different structures of data because different CNC machines have different CNC vendors, so that the structure of data sets sometimes different. So mostly all challenges are connected with subject matter. So the best results are achieved by bringing together scientists, engineers, and manufacturers, operators, and engineers together to build a great solution for this field. Also, earlier, we used different data sets that are not connected with manufacturing. There is lack of open industrial Internet of Things data sets for research and comparison, because we need to validate algorithms on different data because of lack of labels and markups. And also we faced with the lack of desire to invest in projects that may not bring any economic benefits. So to build a strong and great product using using machine learning and data science in manufacture, we need to have pilots, and we need to have projects that may not bring any money to you, but need to we need to measure the results. But every day, a lot of data scientists team work so hard and do their best to overcome these obstacles and these challenges. And I'm happy that the community is growing and expanding all over the world. And it's really inspiring. So I was fast. That's all for today. So thank you for your attention. It's a great opportunity to speak here, and maybe we'll discuss some questions if you have one.
Yes, actually there is, Lydia, there is already one question in the chat. What machine learning tools do your firm, do your company uses? Scikit-learn, TensorFlow, develop own product. What do you use?
Just a second. I'll close my screen. Yeah, we use TensorFlow. Yeah, so we built our products using Python and TensorFlow. Yeah.
Okay. Any other questions? Please write to the chat. There's a comment that half of things was not absolutely clear, but it was interesting.
That's okay.
Okay, maybe some more questions regarding this exact presentation and case. What sizes of data sets were?
We had data sets with several gigabytes, but especially for this particular task, we didn't need to have a large number of time series, because we needed to have at least 50 cycles for to detect the anomaly, and it was it's like 2 or 4 working days of data. So that's not so big for this particular task.
Okay.
Yeah.
Some more questions, because we still have time before the next speaker. So let's ask some more. What the main difference for this domain?
What's the main differences for this domain? You mean what differences there are for manufacturers when we speak about? I didn't get the question, unfortunately.
Let me try to unmute Diana just a second, and she Just a second, I will try to find Diana. Diana, I think that now you can, no, I do not succeed. Oh, why not? Just, yeah, Diana, can you talk now?
Yes, I think. Yes.
Okay, yeah, can you please tell us a little bit more about your question?
Yeah, I'm just interested about this domain, like manufacturing, because it's not like ordinary IT projects, and I'm curious about like what the main differences and maybe important things that you have to, you know, to care, to think about when you're doing something in this domain.
Yeah, for me, thank you for this question. It's great. For me, as a product owner, it was a challenge to understand the mechanics of this manufacturing process, because I'm not a manufacturer. So, and for data scientists that I work with, it was also a challenge to understand how parts are produced, what is cutting tool, and or what is spindle, or maybe other machines components. So, but to solve this particular problem of anomaly detection, and there are experts in this field, and also we need to make some homework, to do some homework. Also, the major difference for this domain is the domain itself. So,
I see. Thank you. And if it's okay, may I ask another question?
Sure.
Yeah, sure.
It's actually not about exactly machine learning and data science, but you said that you are a product owner, and I'm really, really curious in this role as maybe future my career path. So my question is, how do you think, what is required skills and I don't know, maybe some knowledge, what are required to take this role, to be able to manage it?
Yeah, that's a great question. You know, product owner is a job that consists of different skills. For example, project management and product management. So it's kind of both. And the most important skill for me is to not be afraid to make mistakes, because you need to test different hypotheses, and not all the hypotheses are great in the end. So for me, this is the most important skill, because other skills can be trained with the help of a lot of in Coursera or somewhere else. So not to be afraid of failure.
Oh, I see. Thank you. It's really challenging sometimes to do mistakes. Can you, just the last one, can you recommend something to watch, to read, or I don't know, to try in order to get this knowledge and understanding of product owner position?
Yeah, I really liked the course in Coursera, which is called, if I'm not mistaken, software product management. So it covers both project management and product management.
Oh, thank you very much.
So it's really basic job. Yeah, thank you for your questions. I've seen some.
Yeah, there are some more questions. How many features do you extract from the data? This one we have already answered. No. How many features do you extract from the data set? Yeah, but yeah.
Yeah, we extract at least 15 parameters. Most of them are from the CNC machine, and at least 6 we have from special sensors, vibration diagnostic sensors. And we have some root mean square from the vibration, peak factor, kurtosis, and just like that.
Okay. What the average time to create this type of projects? I mean, with all the steps in production.
If we speak in, because it's not like piloting, maybe POC, proof of concept projects, we need to, so the step 1 is to understand whether the data is collected on the manufacturer factory. If it's not, we need to have either our own product to collect data, or to make them by some other products. So we need to have at least maybe 6 months of data just to collect it, and then we can use the historical data to try to train some models to show that machine learning can help them. Because the challenge is that most of engineers and operators on the factory, they do not understand how machine learning can solve their problems. So we need to have a POC, a proof of concept, to show them that there are good and great results with machine learning. And then we so we can have POC on one machine, and then if it's okay and they like the results, we can use these models for hundreds of the machines. So at least 1 year, yeah, to have measurable results, and then just to invent solution on all the machines they have. Solution on all the machines. Doing a really good course for ML beginner. I guess I really don't know because I know that there are great courses in Coursera from IBM for machine learning beginners. Also, maybe you should take courses on Python for beginner because there are specifics for it. And how many specialists work on the project, and what are they? Great question about the team. We at Cifre have at least 100 specialists, but we have different teams for different sectors. Our team that works with manufacturing and metalworking, we have in Scrum team, we have 3 data scientists, 1 lead data scientist, and 2 junior middle data scientists. And then me as a product owner, and also we have business analysts that work with subject matter experts to understand the business value of this project and product. So at least 10 people in one team for one project or product.